Simeon is doing his bell work. Aaliyah is about to start. Armani is doing her bell work silently.
Malik is finishing bell work.
Good work silently doing your bell work, everyone. No diamonds. All right, I finished attendance. Take another 2 minutes to do your bell work thoroughly.
I'm not talking to you. All I wanted to do was go to the bathroom.
Oh, yeah.
No.
Take 1 more minute. All right, I'm going to come around and start stamping. When I'm finished, we'll go over it. Oh, where I would have stopped.
Yeah, you can hear from a distance.
All right.
I'm Bill.
Guys, if you're finished, just hang on a second, all right? Okay, good morning, everyone. So, just a couple announcements. Yesterday, a couple of you were out. We went over. Excuse me. We went over the project yesterday. Please see me, or I'll see you. We'll connect. It's due March 11th, though. That's just so that's on your radar.
What?
Please don't call out. Okay?
Ooh. Oh, you got some nerve, bro. Yo. Alright. Yo, I know Gordon. I just said that. Oh.
All right. So today, by the end of today, you will be able to solve a system of linear equations using the graphing method. You'll see what that means momentarily. In the meantime, let's connect what we'll be doing today with skills that we've already done. here in our bell work, we have two skills. Evaluating a table of values using a linear function, which I give you, and then graphing that linear function. Alright? Can I have someone raise their hand and tell me what form is this linear function in, Armani? Slope, intercept form, right? Slope, intercept form. Okay? The slope is 1/2, the intercept for the b is +2. Good. Alright, so when we complete this table, right, we evaluate here. Can someone tell me what they got? Raise their hand for the completed table. Charles. 0, 2, 3. Let's see.
1, 2, 3.
Yeah, I got 1, 2, 3. 1, 2, 3. Alright, so basically, we put the x values into the function, right? -2 plus 2, half of -2 is -1, plus 2 is +1. Good. A half times 0 is 0, plus 2, +2. Good. And then finally, half of 2 is 1, plus 2 is 3. Good. So that's it. Now we know we graph. What's the first point we graph? Someone give me a hand. First point we graph. Thank you for your enthusiasm. Someone who has not answered yet.
What was the question?
Please, what's the first point we graph? Okay, -2, 1. Sure.
I mean, stop.
-2, 1. Good. What's next? 0, 2, right? Lower.
So Brian,
0, 2. And then finally, 2, 3. Right? Good. And you connect the points. Alright, please take your classwork out. Please take your classwork out for 15 seconds. Let's go.
I'm Paul.
What? Let's do. Oh, this. Yeah, hold on. What? Yeah. All right. You should have the classwork out in front of you. All right. In the meantime, I'll be back in 1 minute, less than. Correct these two equations up here. Can you see that? Those corrections in red? Okay? Correct them. See the changes right here being made? Make those changes on your paper. These functions, change the functions.
Kid. You started yelling, me too. I'm not even in other words. No, because he should give me he should have been her.
All right, we good?
No.
Okay, so, as you can see, we're gonna complete this table, all right? One table for each function. Then we're gonna graph. The intersection of the 2 points will be the solution to the system, all right? So, put the -3 in, right? And what do you get when that happens? 2 times -3, -6 plus 3, -3, right? So your coordinate is just the x and the y, okay? Then, for the next one, the x value is -2, so I'm substituting that in. -2 times 2, -4 plus 3, -1. So your coordinate will be -2, -1. The y value comes second, don't forget. X first, y second. Then, substitute in -1. 2 times -1, -2 plus 3, +1. So it's -1, 1. 0, easy number. You'll end up with 0, 3. 1, also an easy number. 2 plus 3 is 5, with the next value of 1. Next, 2. 2 times 2 is 4 plus 3, 7, with the next value of 2. And then finally, 3 times 3 is 9 plus 3 is 12, right? With the next value of 3. That's one table for one function, the first function, 2x plus 3 up here. All right? Let's quickly do the second. Real quick, I'm going to just substitute these in. Negative 3 plus 2. Negative 1, right? Negative 2 plus 2 is 0. Negative 1 plus 2, 1, right? Positive 1. 0 plus 2, 2. 1 plus 2, 3. This one's a little bit easier, right? Because there's no, the slope is 1. 2 plus 2. Good. 4. And 3 plus 2. 5. Great. Okay. So now, what we're going to do with this is we're going to graph it on this coordinate plane. Okay? The points that we just plotted. Or you also know how to just graph a line based on the equation. Okay? So that is your reference. Well, once you plot 2, you can draw on a line, then you technically have hit all the points, right? So no, as long as you can graph correctly, I'm not going to be a stickler about you graphing every single one of these points. Okay? So this is actually a little bit of a review of how to graph from y-intercept form, right? So you could, however, as we know, plot these coordinates, they'll line up, connect them to a line. However, I'm going to do the other way. What's my y-intercept? Someone raise their hand. Armani. How do you know that? You're correct. It's in the equation, right? Y equals mx plus b, right? We know that form. Good. So come down to your graph, plot your y-intercept at 3, right? And what's our slope? 2, as we said. So up 2 over 1, up 2 over 1. You can also go down 2 and over 1, down 2 over 1. Positive slope, we expect an upward sloping line. I'm just plotting more points using the slope. Remember the rise over run method? I start at a point, I'm going down over 1, down 2 over 1. Okay? You want to connect that, all the dots. Alright, the next one is x plus 2, right?
I got another paper.
Y-intercept of 2, slope of 1, up 1 over 1, up 1 over 1, 1 over 1. Right? See the pattern?
You got part that too?
Yeah, 2 is the y-intercept for the second function. Connect. Alright, so there you have it. 2 lines graphed on the same plane. Alright? Where they intersect. Where they intersect is the solution to the system, which you solved by graphing. That's today's objective. Solve the system of linear equations using the graphing method. Do you see that the lines intersect at this point here?
No.
If you graph correctly, they will.
Well, I didn't graph like that. I
Okay.
graphed
Alright? So whatever this coordinate is your solution. Review, and you could have also plotted those points.
I did, and it came up.
You also changed this one.
I did.
Okay, so the solution then, -1, 1, right? So the solution is -1, 1. The solution to the system, which is 2 graphs on one is negative 1, 1, because that is where the intersection point lies. Do we see that the lines crisscross here? When I say intersection, I mean they cross each other. Okay? Great. So the next one. The equations you'll notice in B. These two equations, what form are they in? Someone give me a hand. Hold on. It's not point slope. Please raise your hand. Not slope intercept. These were slope intercepts, remember? Mx plus b.
Yeah.
There's only one more. Standard form, right? Standard. Ax plus by equals c. That's the general form for it. So we want to just rearrange these into slope intercept because that's how it's easiest to work with, okay? So let's do that. What are we going to do with the 4x to get into slope intercept form? Aaliyah, what do you think? No, we want it to look like y equals mx plus b, remember? We want it in slope intercept form. We want it in slope intercept form, right? So, we don't need the, what do we need by itself? Not the x, we need the, what by itself? The y, right? Because it's y equals, y is alone on the left side, right? So now what are we going to do with the 4x? No, so if it's a positive 4x, we want to move it across the equal sign. Right? Then it'll cancel here. So y, you're left with a y minus 4x plus 2. Guys, we did this. There's no need for apologies, just learn it now, okay? It's not something to apologize about. I'm just letting you know that we covered this, okay? This is a keystone class. You have a difficult exam coming up at the end of the year. Not to mention, these skills are foundational to the success of you in your future math classes, okay? I showed you some pre-calc yesterday to let you see how what we've done is directly related to what I'm doing with pre-calculus right now, okay? These things do connect, they do matter. Please remember that. All right, the x minus y equals 3. What are we going to do with the x? Same thing. Add it. Add it. Well, not add it, right? It's already positive because it's a plus x. So we're going to do the opposite, right? So minus x, minus x. The x's will cancel. You'll be left with minus y equals negative x plus 3. But we don't want a minus y, right? What kind of y do we want? Positive, right? So, what am I going to do to make this positive? You're not going to add y. What's the number actually in front of the y? A 1, right? So we're going to, hold on. So really, when you see a negative in front of something, a variable, in front of a variable, it's really a minus 1. We've talked a little bit about that, okay? So, essentially there are two things being multiplied together. To undo multiplication, we divide, right? So we're going to actually divide both sides by negative 1, okay? And when you do that, essentially what happens is these signs are going to change. So you get y equals positive x minus 3. Right? Because you're just dividing. Negative x divided by negative 1 is a positive x. Positive 3 divided by negative 1 is a negative 3. Okay, so basically, essentially the signs are just flipping. All right? Now at this point, I trust that you can complete the table, so we're just going to actually graph these using the equations, okay? Because this is a more important skill anyway. All right, so our y-intercept is what? Malik, what's our y-intercept of the first function right here? 2, right? Positive 2, awesome. Good job. So I plot that point, right? The second thing I do is perform the slope.
It's gonna be -3.
What's the
Oh,
slope?
The slope,
Go ahead.
I was right, wasn't it?
I didn't hear you.
It's -3.
Hold on. The slope of this function.
Oh, that slope.
I was confused too.
We're doing this first one right now. Jimmy, here. It's -4/1. Awesome. Great job. So, you can, from this point, remember, just go down 4, right? Over 1 to the right, because it's a negative slope, right? So we need a downward sloping line. So 1, 2, 3, 4, over 1. That'll be another point. The next point would be like right here, a little bit off the graph, okay? And the next point would be here. Again, that's just the rise over run method. Change my color to do the second one. Y-intercept of this one. -3, right? Good. Go down to -3. Remember, the y-intercept has to fall on the y-axis, right? That's where it gets the. And then finally, our slope is just 1. We talked about this too, and it's just an x, it's a slope of 1. Really easy slope, up 1 over 1, up 1 over 1, right? So go up 1 over 1, so there's a point, up 1 over 1, there's a point, up 1 over 1, there's a point, up 1 over 1.
Yeah, Mr. Umar, can you say, I can't see from the distance.
Sorry, can you see better now?
Yeah.
Okay. And then connect the points. Ramani, you have a question?
No.
Okay.